Next we will discuss the dot convention. So when we discussed about the voltage polarity on the secondary winding, we always took the winding, right? We know the sense of winding. That means a winding can be either wound in this manner or it can be wound in another manner like this. So you can see there is a difference between the first and the second one. Okay, here what is happening in the first one, if you send the current like this, then this will be the current direction in the coil. Then what will be the direction of flux? The direction of flux will be in the upward direction, phi. Okay, and when it flows around, this is going to be in the clockwise direction. But the same coil, different sense of winding, if you are giving the current in the same direction, now what is happening? The current will now flow in this direction. So what will be the direction of the flux? It is going to be in the downward direction, right? So this is going to be in the counterclockwise sense. So the sense of winding is very important because it decides the direction of the flux. Okay. So anyways, from the previous discussions, we already know how to get the voltage polarity on the secondary side given the sense of winding. Okay. So here what is the case? This primary winding is driving a flux in the clockwise direction. So the polarity on the secondary winding should be such that it drives a flux in the anti-clockwise direction. So if flux has to be driven in the anti-clockwise direction, current should be in this direction. That means current should be induced in this direction. Okay. So what will be the voltage polarity then? Here there should be a positive polarity and here the negative polarity. Okay. So now this winding will act as a source and it will drive the current in this direction from its positive terminal. Okay. So this is anyways done. But oftentimes practically in the transformer we will not be given access to the sense of windings. Okay. Now in that case, how to solve this problem is to use this dot convention. Okay. What happens here is you take the two windings and a dot will be assigned to one ending of each winding. So let us say this is the dot convention for this transformer. So what this means is if the current is entering the dotted terminal, okay, then the polarity on the second winding dotted terminal is going to be positive. Okay. But if the current is leaving the dotted terminal, then this dotted terminal will become negative polarity. So you can write if a current enters the dotted terminal of primary, then positive polarity is formed at the dotted terminal of secondary winding. And if current leaves the dotted terminal, then the other dotted polarity terminal is going to become negative polarity. Terminal of primary, then negative polarity is formed at the dotted terminal of secondary. Okay, so this is the dot convention.